Hello, everyone. This is a crash course on trigonometry. It's not going to be done in one sitting, in one lesson. I thought about the need of you who have or have not taken trigonometry and the need that we are going to have for the calculus series. This is how I have come up with a plan to try to make it as short as possible, and hopefully it will be made as useful as possible for you. I vision there will be three lessons on trigonometry. I call them ABC. The first one is going to be on, of course, the most important part, which is definition, okay? There are three elements in trigonometry. I would say that these three elements in trigonometry define the entire course, okay? The first one, I call it A, okay? ARD. So we start with A. A is about angle measurement. Angle measurement. What about angle measurements, right? The angles we use for the 6 trig functions, and they are the input for the functions. So we kind of call them angles. In most cases, we prefer they're measured in radians, or in some other cases, so for those of you who have taken trigonometry at the beginning, you might feel, I like the degrees better. But by the time you are in calculus, we expect everyone to use radians. We're going to talk about that a little bit more. But for the moment, we just know how angles are measured, regardless it is degree or radian. Okay, so we just talk about, so A is about angle measurement. The positive angle. Okay, so we have positive angle and negative angle. Every angle is measured from the same position, which is the dark black line I have drawn in this picture. Okay, so that's the starting position to measure any angle that is going to be used as the input for any one of the trig functions. And these angles may be positive or may be negative, okay? So let's see how we call it a positive angle. A positive angle is measured, okay, from this position counterclockwise, okay? So the angle measured counterclockwise. Okay, what we mean by that is that suppose we measure angle. We measure an angle and we want it to be a positive one. And what we do is that we start from here, okay? And we go counterclockwise. We go counterclockwise. And we can keep going. Okay, so this is the counterclockwise measurement. All right. Now, negative angle. Negative angle is, of course, you guessed it, is measured clockwise. So measured clockwise. Okay, so this is about angle measurement. That's the most important element in trigonometry and in everything about trigonometry. Okay, every angle is measured starting from the same position, either counterclockwise or clockwise. Okay, the second concept we're going to use in trigonometry is called reference angle. Okay, what is a reference angle? We have a definition about reference angle. A reference angle is the positive acute angle. Okay, so number one is a positive. Second is acute. Third, what kind of angle, right? Positive and acute angle, right? Between the terminal of the angle and x-axis. And x-axis. Okay? So what do we mean by that? For example, we just measured angles, right? Starting from the same position, counterclockwise. Counterclockwise. If I terminate right here, then between this red terminal is called the terminal of the angle. And the angle is between the dark black and the red. Okay? And this angle obviously is less than the straight angle. So it is positive, acute. Acute meaning is between 0 and the straight angle. Okay, straight angle in degree system is 90 degree. In radian system is pi over 2. Okay, so let me write it down. So this angle, I will call it reference angle R. Okay, needs to be positive. Positive means larger than 0. Larger than 0. And smaller than, acute is smaller than 90 degrees. 90 degrees or pi over 2. Pi over 2 is a radian. It's a radian. Equivalent to 90 degrees. And now our reference angle is right here. In this case, our reference angle is this piece. I call it R. Now, then you say, well, I'm going to measure. I'm going to keep going. I terminate in the second quadrant. Okay? In the second quadrant, between the terminal and the x-axis would be this angle. Would be this angle. Okay? And that will be the reference angle. So we're going to take the positive value. Then you say, what if I measured that terminated, right, in the third quadrant? In the third quadrant. And that reference angle will be here, between the terminal and the x-axis, and we choose the positive value. Between 0 and 90 degrees, or between 0 or pi over 2. And then you say, well, I'm going to measure a negative angle. If you're measuring a negative angle, you're going to go clockwise, and you terminate in the fourth quadrant. And what will be the reference angle? Well, in this case, the reference angle will be the terminal between the terminal and the starting line. Okay, so that's going to be the reference angle. You can see in each quadrant, we will have a way to determine the reference angle. Okay, so that's the reference angle. So there are three elements about reference angle, positive, acute angle between the terminal and x-axis, okay? So now let's put that away. P. P is about the definition of all 6 trig functions, okay? The definition. We can call it definition. Definition, definition, definition. All right. Before we start the definition, we make some assumptions, okay? We say x comma y is a point. Is a point on the terminal side of an angle. I will give a name to this angle. Angle, we call it A, capital A. Okay? But this point, we have a special requirement about this point. Okay, x comma y is the point on terminal side of an angle A. Okay, other than the origin. Other than the origin. That is to say that this point cannot be equal to 0 at the same time. X and y cannot be equal to 0 at the same time. So we typically use mathematical expressions like this. This just means if x is 0, y cannot be 0. If y is 0, x cannot be 0. Or x, y both cannot be, are not 0, okay? But one of them can be 0. So this is the assumption. So once this assumption is made, okay, once this assumption is made, we're going to define another critical number. Okay, we say let r equals to the square root, equals to the square root of x squared plus y squared. Okay, because x, y are not 0 at the same time, so we can be certain, right? So in your mind now you're thinking, well, the choice of x, y according to this requirement, r is always going to be positive. Okay, so but this is not mentioned in the official definition. Okay, but we know, we draw a conclusion from it. So once we have these r defined, we have r defined, we have x, y. So we have 3 numbers, x, y, r. Okay, so let's see how many scenarios could there be? Okay, how many scenarios could there be? I have chosen some examples. Okay, so the point, right? Because this point is on terminal side of an angle A other than the origin. So this terminal could be in any one of the quadrants. It could be in any one of the quadrants. Okay. Now we're going to introduce the definition. We're going to look at the examples in a little bit. All right. So sine of A equals to, right? We have 3 numbers, x, y, the consequential r is equal to y divided by r. Okay? And cosine A is going to be x over r. And tangent of A equals to y over x. And we have 3 numbers, right? 3 numbers, we arrange them in different order. We come up with 6 different ways of using these 3 numbers. And the other one is cosecant A equals to the R over Y. So we basically, we reorder Y over R into R over Y. Secant. Okay, so secant of A is, you guessed it, it's the reciprocal of cosine. So that's going to be R over X. And cotangent would be the reciprocal of tangent, which is going to be X over Y. Okay, which is going to be X over Y. So from these discussions, right, we can see the domain. We can have some discussions about the domain. Domains, right? Because sine of A is Y over R. Okay, take one of the examples. Take one of those examples. Okay, we're going to apply the definition, right? We're going to apply the definition, and we're going to take one examples, which is going to be the examples I've chosen here, 3, 4. 3, 4. Okay, I'm going to plot this point. I'm going to plot this point right there. Okay. In the rectangular system, I'm going to make it a black dot. Okay, so that's the point. X equals 3. Okay, Y equals to 4. And we got the angle. The angle is going to be like this. Okay, so let me draw the terminal. Right there. Okay, so this is the terminal, and that's the angle A, right? So this is the angle A, all right? So you can see Y, okay, let's see what is Y. Y is this line. Y is this line, okay? Okay, I'm gonna make it blue. Okay, and X, I'm gonna draw the X line. That's gonna be the red, thicker, right? So X is the 3, right? We look at that example, 3, 4, 3, 4, right? So the red is 3, the blue is 4. What will be the R in this example? The R in this example, well, R is defined, right? So X equals to 3, Y equals to 4. According to the definition of R, we just have to take this definition of R and we put it in there. So this is going to be 3 squared and this is going to be 4 squared. Yes, I did choose numbers that it's not difficult to calculate, okay? And here we go. This is 9 plus 16. 9 plus 16. 9 plus 16 is 25. The square root of 25 is 5. So now let's see. Okay, so this is 3, and that is 4, and this is 5. Okay, So you can see the hypotenuse is always longer than the two legs, whether it's 3 or 4, or in any right triangle, the hypotenuse is always the longest. When we take one of the leg to divide it by hypotenuse, and of course, sine of A is going to be less than or equals to 1. Less than equals to 1. The longest hypotenuse, it would be the leg is the same length of hypotenuse, right? So in that case, it's less than equals to 1. It could also be that y is negative. Therefore, it's obvious that sine is between -1 and +1. Okay, so it's just by our common sense. How about cosine? Cosine is also between -1 and 1 for the same reason, because cosine is x over r, okay? X over r. X is one of the legs, right? X is one of the legs. The leg is always shorter than the hypotenuse. Therefore, for cosine, it's also between -1 and +1. We know that we're going to use this in our calculus classes, right? About the domain of sine and cosine. Then how about tangent and cotangent? How about tangent or cotangent? Tangent and cotangent, okay, their domain, we're going to discuss a little bit later. Okay, so for sine, cosine, we know their domains and the range. The domain, these are the range of sine and cosine. How about their domain? Right, so this is the range. I hope I didn't say anything wrong. So the range is between -1 and 1, which is the ratio. How about the domains? Domains is about the angles, right? So in the whole process, when we measure the angles, so let me clean up this a little bit. In the whole process of measuring angles, right? R is never going to be 0 because the way we chose them. So sine will always be, no matter where we terminate, we always have an angle. So the domain for sine and the cosine is from -infinity to +infinity, because we never run the risk of having a 0 denominator. R is always positive. So we got the range, okay? We got the range of sine and cosine right here. This is from one perspective. All right? So now we have the definition. Of all these trig functions. And now we can derive some interesting, simple relationship, right? From here, you can see sine A and cosecant A are reciprocal to each other, right? So sine of A multiply cosecant of A equals to y over r multiply r over y. And it is equal to 1. The similar work, okay? Cosine A multiply secant A equals to x over r multiply r over x. And that will equal to 1 again. Last but not least, tangent. right? Tangent of A multiply cotangent of A, that's going to be equals to y over x multiply x over y. Provided, no denominators is 0, so this equals to 1 as well, okay? So this will generate some interesting phenomena because that equals to 1, that equals to 1. So we already got some, identities, okay? In a separate video, we're going to talk about identities with more complex identities that we are going to use in calculus series. But now we already got some simple identities. For example, cosecant A is equal to 1 over sine of A, right? And you can also say sine of A equals to 1 over cosecant of A, right? So similar situation applies, right? So we can see secant of A equals to 1 over cosine of A, okay? And continue on this list, right? Cosine A is equals to 1 over secant of A. Okay, you might need some of these in your calculus classes. And tangent, okay? So tangent of A equals to 1 over cotangent of A, all right? And cotangent of A, I'm sorry, typo. Cotangent of A is equals to 1 over tangent of A. So these are the basic relationships and identities we have derived. Now, we have another very important and useful identities, okay, which is sine squared of A plus cosine square of A. What would that be? Okay, we know sine of A is equal to, so we're going to do a direct substitution. Sine square of A basically is y over r squared. And another one, which is a cosine of A, is going to be equal to x over r parentheses squared. And then what do we have now is we got y squared over r squared, plus x squared over r squared, And now we got the same denominator. We got basically y squared plus x squared. We keep the same denominator. So we got r squared in the denominator and y squared plus x squared. And we know that x squared plus y squared is the same as y squared plus x squared, right? It's just different order. So now what do we got? We know that r is the square root of x squared plus y squared, right? So from here, if we square both sides, right, from this piece, if we square both sides, we end up with r squared equals to x squared plus y squared. So we can take this and bring it back to what we have, okay? So y squared plus x squared, we have r squared there, and x squared plus y squared is r squared. R squared over r squared equals to 1. So we have just proved a very important identity, which is sine squared plus cosine squared of any angle equals to 1. Okay, and of course, for those of you who had taken trigonometry, you already know this. For those of you who have not, these are important facts that we use, and we use them often, okay? So all of these will be treated as identities. I wish you guys would derive with your own hands, All right. We have discussed domain and range with sine, cosine. We will discuss domain range for the other 4, but it comes later. So now we're going to apply the definition. Okay. There are 2 aspects I wish you guys to understand. Okay, there are 2 aspects I wish you guys to understand. Number 1 is that we just mentioned ARD. Okay, ARD. Okay, so ARD, and we know what ARDs are. What kind of thing you must be able to do when you are, you're taking calculus class and you know ARD. Okay, there are 2 types of questions you will encounter. There are 2 kinds of questions you will encounter. One is taking you from A to D, and the other one is taking you from D to A. Okay, so any trick questions, they are it's either A to D or D to A. So we're going to see some examples of A to D. Okay, so here we got some examples, and we're going to try to we're going to apply ARD to them, right? With all of these discussions, we have done the definition. So let's look at ARD one more time. So from A to D, I prepared all of these examples, and I wish you guys to work with me from A to D. So all of these questions, okay, so let's do one at a time. Because we're given the terminal, right? We are basically given a point on the terminal. So all of these are a point on a terminal. Okay. So that angle, what are those angles? All right, so I'm going to take this picture and bring it with us. And we know that on this picture we're marked 3, 4, right? We've done some work here. All right. So now let's find the 6 values for the trig function. Okay. According to the definition, which one is the angle? Okay, hold on. Which one is the angle? Right? It terminates here. It terminates on 3, 4, right? How many angles are there that corresponds to this one terminal? right? We're given a terminal, so this angle could be this one. Okay, it could be this one. So this is the terminal. But this angle could also be measured from clockwise. Okay, so I'm going to use some tools to show you. All right, so you can see this is our terminal. So the angle could be this one. But the angle could also be this one. And the angle could also be this one. Okay, you can see for the same terminal, it could be many, many different angles. There could be many, many different angles. So when we choose A, we're going to call them A. Okay, we're going to call them A. Okay, so A could be any one of those angles. It's for one terminal. Sometimes people call it coterminal. Coterminal. All of these angles have the same terminal, right? Now, with that understanding, okay, so with the terminal terminating, passing this point, we call all of those angles A. Okay, we call all of those angles A. So you know that angle could be, it's a class of angles. It's a class of angles. Okay, so we call those angles A. And now we're going to find sine of this angle, which is going to be, okay, let me mark it. And hold on, I'm going to leave enough space because these two software don't talk to each other. Okay, so we consider we know an angle that terminates there, right? And I'm going to mark it. This side is 3, and that side is 4. And we found that as r equals to 5. So the rest is just a matter of plugging numbers. Okay? Excuse me. Sine of A is y over hypotenuse, which is going to be 4 over 5. Okay? Cosine of A is going to be the red over hypotenuse. So 3 over 5. And how about tangent? Tangent of that angle, and the class of angle is going to be y over x. So the blue over the blue. Okay, the blue is 4. The blue line, I meant the blue line, and the red is 3. And cotangent of angle equals to the reciprocal, right? So now we can use the reciprocal. How about cosecant? Cosecant of A equals the reciprocal of sine, so 5 over 4. And secant of A equals to the reciprocal of cosine, which is 5 over 3. You can see once we know that point, we can find all the ratios. That's A to D. That's A to D. Okay? And let's look at another example. Okay, so you can now understand that I have chosen points from different quadrants. Okay, so we're going to see some interesting phenomena. So here I'm going to choose, I'm going to make a table and to put things in place, and I would like you to follow me to do these calculations, to do all of these calculations. So let's make the table. Okay, clean this up. And we're gonna make this table. Okay, table, we should have six columns. 1, 2, 3, 4. Okay, we got 6 columns, 4 points, right? So make it 5 rows. Okay, so the point for the first point, and we have an angle, right? In fact, maybe we need another column. No, we don't. Okay, so sine of A, we got it. So once we know the point, I think we should make a column to put the R, right? But for now, we don't need it. Okay, so let's just put it over here. Copy and paste. Okay, so I'm gonna put it in this way. Tangent. I think we probably need another column. Okay, cosecant. I put a cosecant right next to sine. Secant, I put it right next to cosine. And I need a column for cotangent. And I can guess, I think you can tell why I put them up this way. Okay, so cotangent. Okay, you can choose your own order. But the way I choose these order reflects their relationship there, which they're reciprocal to each other. Okay, next I want you guys to work on these. No, put it over here. This is the third quadrant, second quadrant, and the fourth quadrant. Okay, so I want you guys to calculate the R. Okay, so we do need another column. Put another column for R. So R is equals to, in this case, we've done the calculation of R, so it's right here, right? So what I like you guys to do is that you put this calculation on your table. Okay, so now let's clean this up. We might need some space to do some calculation. So while you guys are doing that, okay, I'm going to mark the other 3 points. I'm going to mark the other 3 points, which is -3, 4, right? In second quadrant. Okay. Second quadrant, we got negative, oh, oopsie, delete. Let me cancel this, okay. The second quadrant is -3, 4, right? There's a dot, all right? And then we will need the red and the blue. We'll need the red and blue, okay? Red is X, blue is Y. And that should be that, okay? And the red. So this is going to be the blue. We got the blue and we got the red. You don't have to know how to use the software. I just need to put them there. So you can see that's -3, 4, right? And next, we're going to put the third point there, which is a -3, -4. Okay, so that's -3, -4. And it's a point. It's a point. Okay, that's that point. And we can draw the terminal. We can put that terminal in there. Okay. That's the blue. Okay. And let's get to the red. That's the red. We got the red. We got the red already. They overlap. Okay. And another piece, which is, I'm just going to add it here. -4. So we're going to have all these points. I want that to be thinner. Okay. And last but not least, the fourth point. The fourth point is going to be 3, -4. You can see, why do I choose point this way? Because we want to experience different quadrant, and we're going to have some interesting conclusions to draw. So that's another dot, and we will draw that's the, let's get the blue. That's going to be -4. That's the blue. And red is already there, right? So you can see the red is actually shared. Okay, we notice that. And last but not least, so we draw all 4 points. 3, -4, and that line is drawn. Okay, so all 4 points. By this time, you probably have finished. Okay, well, you have not. Okay, so let's do it together. In the second case for R, you can see 3 is a negative. It's a -3. But -3 squared is also 9. So we also get a root 25, and that equals to 5. So in fact, you can see it doesn't matter whether R is positive, but whether X is positive or negative, right? Because in this case, after you square them, all the negative numbers turn into a positive. So this equals to 5. I just want you to see that R is always a positive indeed. Okay, so that equals to 5. So we save some space. Okay, we're going to save some space. So R is 5. R is always positive. This is not a proof R is positive, right? We already proved it, but it's just we see it concrete, right? And then to find these 6 functions, this is so we are doing A to D. We're doing A to D here. We're doing A to D, okay, to emphasize, because I declare all the questions we will encounter is either A to D or D to A. So A to D, A to D. So the second one, sign of A, of course, this is a different A, which is terminal over here, right? This is the terminal, right? In the second quadrant, and that's going to be Y over R, Y over R, okay? And Y is a 4, right? Y is a 4, R is a 5. Different terminal, same ratio. Isn't that interesting? And of course, the cosecant A, we found it. Cosecant A is going to be the same, which is a reciprocal of sine. And secant, cosine of A equals to, cosine of A is x over r, right? So x over r, x in this case is a -3. So we're going to put in -3 over r, which is a 5. So it's a -3 over 5. We can put a negative sign in front of it. And secant of A, of course, this is the other angle terminates over there. That's going to be negative 5/3. And tangent of the angle, of course, this angle terminates in the second quadrant. In the second quadrant is going to be the blue over red, right? So it's a 4 over -3. So it's just a -4/3. Put a negative sign in front of it. And cotangent A, okay? And that's going to be the reciprocal of it. So it's going to be -3/4. All right. So now let's look at the third point, which terminates in the third quadrant. Third quadrant, right? This terminal. In this third quadrant, okay, maybe I should do some markings for you, right? So on the third quadrant, okay, so this is the terminal, right? This is the terminal. And we also call it A. We know it's a class of angles, right? So this is a sine of A equals to y over r. Okay, y is -4 and r is a 5. It's a -4/5. We put a negative sign in the front. And cosecant of A equals the reciprocal of sine of A, and that's going to be -5/4. Okay. And how about cosine? Cosine is going to be x, the red over hypotenuse. The red is also a negative, which is a -3, -3/5. And that's, we can put a negative sign in front of it. And secant of A, which is going to be the reciprocal of it, which is a 5/3, and there's a negative sign. And tangent is going to be blue over red, right? So -4 over -3. Well, negative divided by negative is a positive, so it's 4/3. How about cotangent of A? That's going to be equals to the reciprocal of it, 3/4, right? So next, the last point in our selection. Okay, the last point in our selection is, once again, the terminal is over here. So now the terminal is going to be in the fourth quadrant. This piece, that's the terminal. We know there are many angles, and our angle A is just a representation of a class of angles with the same terminal, right? So sine of A equals to, once again, y over r. You can see we just repetitively using the definition. But be patient with ourselves, please, here, because we are going to see something interesting after we're done with this, and I hope I'll lead you there. Okay, so cosecant of A equals to negative 5 over 4. Cosine of A would be equal to x over r. X here is 3, r is 5. And secant of A equals to, let's see, the reciprocal of cosine, right? That's going to be 5 over 3. Tangent of A equals to blue over red. So negative 4 over 3, right? That's a negative 4 over 3. Put it in the front. And cotangent of A equals to the reciprocal of tangent. So that's negative of 3 over 4. All right. So then if you say, well, these angles are pretty confusing because you call them by the same name, I agree with you. I agree with you. Actually, they look pretty confusing. So I'm going to make a little change so you understand that these different angles. I can just call them different names. For example, I'm going to call them different names. Say this is A. So we agree this is A, right? And it's a class, right? We know this could be the other angle A. And how about another one? So for the terminal in the second quadrant, I'm going to call it B. And then all of these angles will be turned into B, right? We can totally do that. So this is just a B, right? This is just a B, 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 oops, B, right? Just all called a B. If that makes better, okay? And continue that I have another terminal, which is terminal in the third quadrant. I call it C. We know that this is a whole class of angles, so that's a C. So now here, we're gonna call them C. So if this is clear for everybody, that'll be great. That'll be great. Okay, and the last but not least, the angle that terminates in the fourth quadrant over here, I'm going to call it D, right? I'm going to call it D. No problem. We're going to call it, this time I'm going to use a capital D. So by this time, I will be calling this angle, they're all D, 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 D. If that helps, But in general, we typically call them by sometimes the same name, but except in one particular question, if there are different angles, we should call them by different names, okay? So so in one particular question, we should not all call them A. I know that could be confusing. If there are different angles, we should call them by different names. I think this way I have made it right. Now, we want to look at these ratios. It looks like if terminal in the first quadrant, the terminal is in the first quadrant, all these ratios are positive. All these ratios are positive. So everything is positive. Okay. So let me do this. I'm going to copy this picture to the next, okay? When the terminal is in the first quadrant, all the functions has a positive ratio. Positive ratio, okay? All of them. So that's something interesting to know, right? That's something interesting to know. So we're going to write it down as all ratio, all positive, meaning the ratios are positive. Okay, so now how about the terminal in the second quadrant? The ratio in the second quadrant. When the ratio in the second quadrant, we can see sine, cosecant are still positive, but cosine turn into negative, and tangent and cotangent are negative. Okay, so sine and cosecant stay the same positive, but cosine, tangent, secant, and cotangent are negative, right? So in the second quadrant, we got cosine, okay, cosine, secant, oh, hold on. Cosine is negative. Tangent is negative. Tangent is negative. Cotangent is negative. Cotangent is negative. And what else? Secant is negative. And sine is a positive. Positive. And cosecant is positive, right? So this seemed to be rather, I would say, pretty complicated, right? Which doesn't need to be. So how can we tell which one is positive, which one is negative, right? Because you can see, let's finish this this round. I'm going to show you another way to tell the positivity or negativity of these functions in each quadrant. This is just one perspective, okay? Because from this particular example, in the third quadrant, on the terminal in the third quadrant, okay, cosine is negative. Sine is negative, cosine is negative. Tangent is positive. Okay, tangent is positive. So in this quadrant, sine, cosine are both negative, and cosecant and secant are both negative, and tangent are positive. All right. So in the fourth quadrant, sine continue to be negative, cosine is positive, and tangent and cotangent are negative. So how do we summarize this in a more meaningful way? Okay. So I'm going to first write it down. Okay, in the third quadrant, okay, sine is negative, cosine is negative, tangent is positive. I kind of skipped the cosecant and cotangent because their reciprocals have the same sign. Okay, last quadrant, last quadrant, okay? Last quadrant, sine is still negative. Cosine is positive. Cosine is positive. And tangent is what? Tangent is negative. Okay, so that's what we see. That's what we see. Okay, so record this, but I have another way to tell you, which is easier than this. Of course, from this example, we can reflect on these positivities, right? The third way to observe is positive or negative. I'm going to go back to the definition. We're going to go back to the definition. This is how it works. Okay, let's see how we do it. This way, you don't have to see any examples from the definition. We can tell. All right. So now, suppose from sine. Okay, from the definition of sine. Okay, sine of any angle is y over r. We know that r is always positive, right? R is always positive. R is always positive. So if y is positive, sine of A is positive. If y is negative, sine of A is going to be negative. And where are the y positive? Well, in the first and second quadrant. In the third and fourth quadrant, y is negative. Therefore, for sine, okay, for sine, the first quadrant is going to be positive. Second quadrant is positive. Third quadrant is going to be negative because y is negative. And the fourth quadrant is negative. So that's for sine. So now you have figured out. Okay, now you can figure out. So let's do this together. Okay, so what I'm going to do is I'm going to clean this up. Okay, I think you got the idea. Okay, so we're going to do this together. Y, and this is for sine. This is for sine. I'm also going to make a table. I'm going to make a little table so we can tell. But on this table, I'm only going to choose 3 functions because we don't need to worry about the other 3. Okay? Excuse me. Excuse me. So the first quadrant, let's see, how many rows do we need? We need just 4. Make 4. Okay. From definition, sine, cosine, right? Cosine. I'm a lazy way to write it down. Tangent. Okay, so tangent. Tangent, and this is y over x. Y over x. Okay. All right. If we understand the quadrants, right? So we probably need another column for quadrants. Okay, insert column there. Okay, so this is a quadrants. All right, one more row. Wait, oh, I'm sorry, I changed the column. Okay, one more row. Wait, sorry, I should choose the row, sorry. There we go. Quadrant 1, 2, 3, 4. Okay. When the terminal terminates in the first and second quadrant, y are positive. Sign is going to be positive in the first quadrant, positive in the second quadrant. Third and fourth, they're going to be negative. Cosine, okay, sorry, this needs to be removed because this is x, right? X in the first quadrant and the fourth quadrant, they share the same red. So the first is for cosine is going to be positive, and the third and the first is positive, the fourth is positive because x is shared by these two terminals. Second and third, the shared x is negative. So x is negative, denominator is positive. So this is going to be negative, negative. How about tangent? Right? How about tangent? Tangent is y divided by x. When y is positive, x is positive, which in the first quadrant is positive. In the third quadrant, y is negative, x is negative. So in the third quadrant, tangent is positive. And in the second and third, second and the fourth, it's negative. So you can see from this one example, we can observe so many things, all right? So this is the, we can have many different terminals, but in general, these four are typical examples, All right. Next one, we're going to talk about D to A. Okay, so A to D, we did A to D. Let's look at it D to A. What kind of question would that be? D to A. What is D to A? This kind of question you might encounter in calculus classes, not only calculus 1, but also could be in calculus 2. Okay? D to A, what does that mean? Example. Okay? You are given an equation, the sine of A equals to, say, 4 over 5. 4 over 5. Okay, you can see, instead of given us a point, right, we are told the ratio is 4 over 5. The ratio is 4 over 5. And it's a positive 4 over 5. Okay, it's a positive 4 over 5. So in this case, we are being asked to find all possible angles A. We asked to find all possible angles of A. What do we do about this? Obviously, we're going to have to represent all these different angles, right? Because we're not going to stop until we find all possible solutions. In this kind of question, we will have to ask, what are the terminals that will cause sine of A equals to 4/5? Obviously, we're going to go by definition. We're going to go by definition because we know by definition, this will be Y and this will be R, right? That's Y, that's R. So what are we going to do? What are we going to do about it? If we know Y, we know R, right, which is the hypotenuse, and we know Y is a blue, right? We can find the red, right? We can find the red. So in this case, we know Y is equals to 4, R is equals to 5, and we find X. Yes, we can, right? Because from the relationship of R equals to square root of X squared plus Y squared, we know, right? We know that R squared is equal to X squared plus Y squared. That's Pythagorean theorem, right? So now we have R equals to 5, Y equals to 4. And we can solve for X. We can solve for X. We can solve for X. Let's see what we get for X. We first get X squared. That equals to 5 squared minus 4 squared. And that's 25 subtract 16. And that's going to be equals to 9. So we got X squared equals to 9. What does X equal to? We're going to take square root on both sides. That equals to the square root of 9. Square root of 9 is a 3. And then what? If your answer is X equals 3, you're wrong. I would say it's incomplete. Incomplete. Okay? Incomplete. Why? Because there are two numbers. Okay, the square root of X squared is root X. That's equals to, that's the absolute value of X. That's equals 3. So X will end up to be either X equals to 3 or negative 3. So we got two solutions for X. But what does that tell us? To satisfy Y equals to 4, R equals to 5, we have two axes, right? Now, as we are looking for the terminals, is not a singular, there are two, okay? So there are two terminals passing. What are the points? Passing points. What are the points? The points are 3, 4, right? Because Y is 4. The other terminal will be negative 3, 4. So to satisfy all of these conditions we're given, we actually have two terminals satisfy that condition. All right, so let's look at these two terminals. So I'm going to draw these 2 points. Okay, don't worry about why I put a Y equals 0. I just want to get started on this drawing. Okay, I hope you have your paper pencil with you and work with me. And I'm making some adjustment to the picture. All right. So we found there are two terminals. There are two terminals satisfying that condition. And one is 3, 4, that's a dot. And there's another one, -3, 4. Both terminal, okay, will give us the angles, all the possible angles. Okay, we're looking for all possible angles. Okay, this is also called trig equation. So we have two terminals. So how do we represent these angles? Okay, so I'm going to draw the terminals. One line, right? One terminal, another terminal. So this is going to be the other terminal. So we got two terminals. Of course, they can be longer. All right. So how do we represent all the angles that passes? Let's share the same terminals. And so on the first terminal, in the first quadrant, we have lots of angles. So how do we represent them? On the second quadrant, we also have lots of angles. How do we represent them? Okay, so for the first terminal in the first quadrant, okay, I'm going to use capital A to represent them. We have so many of them, right? And then we encounter an issue. How do we find? Okay, so let me grab this, right? So this angle, if I know this angle, I would know the other angle, right? So I'm going to call this theta. Okay? If I know angle theta, and all the angles that terminates on the terminal in the first quadrant will just be theta plus 2k pi. And k, you basically go around and round in any direction you want. Okay, let me show you what that is. So for k equals to 0, right, it's just theta. So theta is one of the solutions. So k equals to 1 is theta plus 2 pi is going to be here and we'll go around. That's a k plus 2 pi. Okay, so let me write it down. That's k. I'm sorry, that's theta plus 2 pi. Okay, let me just write it down because it doesn't type so nicely. Theta plus 2 pi, right? We go we went counterclockwise. But what if my angle is clockwise? I go around twice. So this angle would be theta subtracting 4 pi, right? That's for k equals to 2, right? So you can see if I do 2k pi plus 2k pi, k can be positive, negative integer, then I would represent all the angles. Okay, so remember that. And let's look at the other terminal. The other terminal, the same idea. The other terminal, of course, I need to know what this angle, I need to know the basic angle. I need to know the basic angle. Since I know this is theta, right? And these two, and I know this is theta. This reference angle is also theta. But the angles I want need to be measured from a particular position here. So this angle is really what I wanted. Okay, and this angle is going to be pi minus theta. And there's many different ways to represent it. So I'm just using pi minus theta. Yeah, you see, I use one of the simpler form because the representation can be so many. So the other solution on the other terminal would be that A could be, okay, A could be pi minus theta and plus 2k pi, plus 2k pi. Right? So we got our representation. We got our representation. But the next question would be, how do I find theta? How do we find theta? Okay, so now let me clean this up. You already saw it. Okay, so the general way to express this, the general way to express it, you will see that in some textbooks on this topic, right? Would be something like this, right? We have 2 rows, 2 columns, right? One is theta plus 2k pi, and the other one is pi minus theta plus 2k pi. You know, solution varies, right? And the k is any integer. K is any integer. So both terminals are represented. K is any integer. So we have represented the solution. Now the only question we have left is, what is theta? What is theta? Okay, for those of you who have taken trigonometry, and you know this is not a special angle. This is not a special angle. Since it is not a special angle, how do we represent it? How do we represent it? Okay, so this is theta. Okay, so I'm going to mark it here, and this is a theta. How do we represent it? So at this moment, I want you guys, for those of you who has not studied trigonometry, you just need to know there is a special function, okay, called arcsine. And it takes the ratio of 4/5. It will produce that angle we need, and this is the theta we wanted. For those of you who understand, whether you understand it or not, okay, I'm going to tell you what arcsine is about. Arcsine is a function created, okay? Arcsine is a function that's created. So let me, the theta is shifted, right? I can't make these two software talk to each other. What is arcsine? Okay, arcsine is this function. Whoops, sorry. Arcsine function is also written as arcsine written this way. The input for arcsine are ratios, okay? So x is between -1 and +1, which is the range of sine. Remember the range of sine, right? So the domain is the same as the range of sine. The domain of arcsine is the range of sine. However, the range of arcsine is not the domain of sine. So what is the range of arcsine? The range of arcsine is going to be between negative pi over 2 to positive pi over 2. To positive pi over 2. Okay, what does that mean? What does that mean? Okay, so I'm going to borrow this picture and do some trimming. Okay, and I'm going to delete a bunch of things. Okay, I'm going to delete a bunch of things. I just needed this picture, right? When we define arcsine, in the future lessons, I will explain to you how arcsine is produced. But in this case, we're just going to use it. When arcsine is produced, when arcsine is used, or when we use arcsine, we need to know we no longer have 4 quadrants. Okay, we're going to cross out the 2nd quadrant and the 3rd quadrant. Only the 1st and 4th. And we still measure angles. Okay, so here I'm going to mark that special line. We still measure angles for the range, for the angles arcsine produce. Because arcsine takes ratio. You can see sine takes angle, produce ratio. Arcsine produces, arcsine takes ratio to produce angle, the other way around. So, okay, so let me mark this as comparison. Okay, so sine takes angle as input. It produces ratio, as we all know, y over r. Okay, arcsine, however, arcsine takes ratio as input, produces ratio, we call it x. Okay, I hope this doesn't confuse with the point that we use as x. Okay, it's the ratio. Arcsine take the ratio, we call it x. It is the placeholder, produces angles. So with arcsine takes ratios, one is a positive ratio, the angle will be between 0 to pi over 2. Okay, so for positive ratio, the angle is going to be in the 1st quadrant, measured counterclockwise. For negative ratio, right? So for positive ratio for arcsine input, the angle is going to be measured counterclockwise. For negative ratio for arcsine, the angle will be measured clockwise. And it doesn't go beyond the y-axis. So the angles is only either from negative pi over 2, which measure this way, clockwise, or measured counterclockwise. Okay, so that's arcsine. So we have a ratio 4 over 5, which is a positive ratio. So it's going to produce a angle theta. And this theta, okay, and this theta is unique. This theta is unique. Okay, one and only. Okay, so now we learned that we have just did D to A. We just did it D to A. I know there's some gaps for those of you who has not studied trigonometry before, but for those of you who have studied trigonometry, you probably see a different perspective, because so far I have not talked about special angles at all. Okay, in a lot of the questions in calculus, actually, we don't use special angles all the time. We a lot of cases we use non-special angles. So this is one example. Okay, let's do one more example. Okay, it's also D to A, right? So let's go back to see what we've done. D to A, we know the ratio and we want to find angle, right? So we go by definition, we figure out y over r is y is 4, r is 5. So we figure that out. Okay, and then we find the x's and we decide, okay, there will be two terminals, right? So that's the first example. The second example, of course, we're gonna do cosine, okay? This time we know the cosine ratio, which is, I'm gonna say 3 over 5, the number we are pretty familiar with, right? 3 over 5. So for 3 over 5, the same trick, the same idea, okay? By definition, right, it's x over r. It's x over r, right? It's for x over r, so we know that x equals to 3, r equals to 5. If we know x, we know r, can we find y? Of course. So we're going to be using the same relationship. You see, it's going to be similarity. This one we know y, in the other one we know x, right? We're going to use the same relationship, which is r squared equals to x squared plus y squared. And you probably anticipated what we're getting, right? So we got 5 squared equals to x squared is 3 squared, right? Because x is 3. So 3 squared plus y squared. So we're solving for, we're going to solve for what? We're going to solve for y. And what do we get for y squared? Y squared is equals to 5 squared subtracting 3 squared. And 25 is 5 squared and 3 squared is 9. So we got 16. So now we got a y squared equals to 16. And of course, we take square root on both sides. So square root of y squared is equal to absolute value of y. So now I know you won't make the same mistake, right? So we're going to get 2 values for y. So y is either -4 or +4. So according to this information, we have x equals 3, y equals to -4 or 4, r equals to 5. we can draw the terminals. We are going to draw the terminals. Okay? So let's see how we're going to draw the terminals. Okay? I'm going to get my system started. We're going to get our system started. Here we go. Okay, I don't need that anymore. Making some adjustment to my picture. Right, so I make the scales. And now we know there are two terminals. There are two terminals, right? Two terminals. So what are these two terminals? These two terminals passing these points. X is 3, right? So these 2 points, two terminals. And there's a X is common, which is 3. Y one time is -4, the other one is a +4. Okay, so let's draw these two terminals. Okay, 2 to the 1 terminal, 2 terminal. This is a -4. 2 terminals. What does that mean? To satisfy the required, we got 2 terminals. We know that for 1 terminal, we have lots of angles. For 2 terminals, how many angles do we have? A lot more, right? So infinite, we really have infinite number of angles. Infinite number of angles, if I put the points in place, so 3, 4, that's 1 dot. Another one is 3, -4. We got terminals. But besides these 2 terminals, there are no other terminals that we'll need to find because we found them all. So the rest is just to represent. How do we represent these? Okay. And let me see, did I draw those? No, I don't think we need to draw those. Okay, we don't need to draw more. I just want to keep it simple. Of course I could, but let's keep it simple. So now the question is, if I find 1 terminal, so suppose this is an angle, I call it theta, right? And because the special situation they're in, and this other one is what? Would be negative theta. So if I can represent theta, right? If I can represent theta, then I would be able to represent all the solutions. So how do we represent theta? Right? So I'm going to leave it blank. I'll come back to it. The solution would be what? All the solutions we can represent, it would be A equals to theta plus 2k pi. You understand what 2k pi means, right? You just go around and around as many times as you wish, or no time you wish, right? You'll find all the angles that terminate with theta, with the terminal in the first quadrant. Or we can use the other terminal, which is going to be negative theta, and plus 2k pi. Okay? And those are also, as you can see, to represent theta is critical. It's critical, right? Do we have something to represent theta? The answer is yes. And in this case, we can use arc cosine, and we use the ratio that was given to us as 3/5. And this will produce a one and only theta. This will produce a one and only theta. So now the solution is complete. So the final solution we can combine into A equals to plus or minus theta plus 2k pi. So for cosine situation, we can combine into one single expression. This will represent all solutions. K is any integer. So all the solutions will be represented. And that's the answer. That is the answer. Okay, so now how about arc cosine, right? Arc cosine, so let's talk about a little bit about arc cosine. The detailed information about arc cosine, I will tell you, I will talk about in later lessons. But for now, I want to give you some information about arc cosine. Okay, so here the final solution, okay, or another way to represent the final solution in this compact form is this, right? If you write this, you would not need to do that. Okay, so just merge into one. Okay, so next we're going to talk about what is about arc cosine. Okay, so I'm going to do something similar to when I did oh, never mind here. Okay. Oh, sorry about that. So I'm just going to redo it. To remove a bunch of points. Okay, delete. Keep this one. Okay. So what about arc cosine? Arc cosine function, right? It is also in comparison with cosine. Cosine takes angle to produce a ratio. Okay, so cosine takes angle, produces ratio. That ratio, of course, is x over r. Okay. This x and this x are different things. Okay, so let's not confuse it. Okay, or red over r. Okay, red over r. So sometimes in order to avoid that confusion, the red meaning the horizontal line. Okay, the red over here. So okay, so let me put it back here just to avoid any confusion. Red over r. Okay, so we got that. Arc cosine, however, takes ratio between -1 and +1, which are exactly the range of sine, a range of a cosine as well. Okay, so the ratio will be the input. It produces angles. Okay. And of course, I want to mark the ratio. The ratio is between -1 to +1. Okay, which is the range of cosine, right? We understand that. The range of cosine, we have talked about it. right? -1 to +1. However, the domain of arc cosine is the range of cosine. But the range of arc cosine is not the domain of cosine. So what is the range of arc cosine? The range of arc cosine is the following. Is between 0 to pi. Between 0 to pi. So when arc cosine is considered, we are not going to use quadrant 3, we cross it out, nor quadrant 4, just quadrant 1 and 2. And you can see our cosine range between 0 to pi, our cosine will never be negative. Okay, so the angle we measure in arc cosine case is always counterclockwise. I know this is a lot to remember, okay, but we will make it manageable, hopefully, for you. And we're gonna make it thicker. Okay, so all the angles we measure for arc cosine is going to be counterclockwise measurement. If it's a positive ratio, the angle is going to be between 0 to pi over 2. This is a positive ratio. For negative ratio, the angle will also be measured counterclockwise, unlike sine, but it's going to be in the second quadrant. All right, so that's all we need to remember about this. Next, we're going to do a last one. Okay, I figure I need to do this one together. Otherwise, it's going to be another lesson. Maybe it's a little too short. Okay, so we have covered D2A with non-special angles for sine, okay, for cosine, and last but not least, which is going to be tangent. Okay, so example, this will be number 3, that we know tangent of A is equals to 4 over 3. 4 over 3. What are we going to do about this? Because our goal is to still to find all possible angles. Find all possible angles of A. How are we going to do this in D2A? Okay, D2A. How do we do that? Well, by definition, tangent is y over x. It's y over x. It's y over x. Right? So this expression tell us x is 3, y is 4. And then you say, wait a minute. Could it also be both are negative? Because negative divide by negative, we get positive. So x equals 3, y equals to 4, or x equals to -3, y equals to -4. So now we have found 2 terminals. So now we found 2 terminals. What are the 2 terminals? 3, 4, or -3 -4. Okay, so let's draw these two terminals. Okay, so we're going to draw these two terminals from the information we just got, right? Because we want to find all possible angles. So from the information given, the two terminals could either be 3, 4 or -3, -4. Okay, so I'm making a little bit adjustment. -3, I'm sorry, -5, +5, -5, +5. So the two terminals are, okay, the two terminals are either 3 to 4, both are positive to get the same ratio, right? Or -3, -4, right? So let's draw those two terminals. 3, 4. This is going to be a line, and that's a dot, and that's a dot. So another one, another terminal, 0, 0, -3, -4, and this time it's a line. Ha! We get two terminals. One terminal in the first quadrant, the other terminal in the third quadrant. Both terminal produce this angle. And now suppose this is theta. Oh, I just like to use theta. You see a lot of books using theta. How do we represent theta? Because once we found theta and theta plus pi, we're gonna get to the other terminal. Plus another pi, we get to the other terminal. So we just have angles. Once we find one angle plus pi, we get the other angle. So this solution, okay, this solution, right? The solution for A would be theta plus k pi, not 2k pi, because if you k pi, you're going back to the previous terminal. K pi, you're basically alternating between these two terminals, and that's a sufficient equal sign, sorry. Okay, so that's all the solutions where there is. K will be integer. Any integer, positive, negative. So you can go clockwise, counterclockwise, you will get all possible angles. So this is theta. Okay, that's why we don't need 2k pi. Okay, because to get to the other terminal, all you have to just plus a pi, plus another pi, or clockwise plus pi, right? So now, once again, we come to figure out, okay, we got the solution, but how do we represent theta? And we're going to introduce to you arctangent. Arctangent. Okay, so theta equals to arctan of x. Once we got theta represented properly, arctangent of 4/3. Okay, sorry, 4/3. So this theta will be uniquely determined. You don't have to worry. It's going to be this theta as a positive ratio. And then all the solutions are found. All the solutions. So solutions is going to be this one. And once again, we're going to talk about arctangent the construction of arctangent later. But for now, you just know arctangent is a very useful function. Okay, so I'm going to show you right now. So arctangent. Okay, so just like a tangent is from angle to ratio, arctangent is from ratio to angle. Okay, so I'm going to put it here, delete some stuff. This is just for convenience, forgive me. Okay, so arctangent. We know that a tangent takes angles to produce ratio. How does the ratio look like? The ratio looks like y over x. Okay, we're going to talk about domain another time. Arctangent, however, right? Arctangent takes ratio, not ration, sorry, takes ratio, produces arctan. Okay, suppose the ratio are x. Okay, this is not to be confused with the x over there. It's just ratio. Okay, it takes ratio. Okay, I'm not using x at all. It produces angle. Okay. We have to mention the domain and range for arctangent. We're going to talk about why later. The domain for tangent is that it can be any real number, but odd number multiples of pi over 2. But the range of tangent is all real numbers. So the domain of arctangent, okay, the domain of arctangent is the same as the range of tangent. Okay, so the ratio for arctangent can be any real number, but the ratio, however, okay, I'm sorry, the angle, however, right, arctangent's range is not the same as the domain of tangent. Arctangent's range is negative pi over 2 to pi over 2. Exclusive, does not include negative pi over 2 nor pi over 2 as it was for arcsine. Okay, so when we are working with arctangent, we understand that we're going to cross out quadrant 2, quadrant 3. Only quadrant 1 and quadrant 4. And it doesn't, and the terminal does not touch the y-axis. Okay, so I'm going to draw some broken line on this, on the y-axis. Actually, I can draw better with the software. I'm sorry. Okay, I'm going to draw better with the software. Okay, to show you the range and the angles. Okay, so that's going to be, oops, it's maybe 10, 0, 10. Okay, you don't need to worry about the grammar. Broken line, that's what I want. Okay, so that's this broken line for arctangent in terms of range, So this quadrant is out. This quadrant is no flight zone. So in terms of the range of arctangent, if we have a positive ratio, okay, if we have a positive ratio, arc tangent will produce angles measured counterclockwise. If it's a negative ratio, it will produce angle measured clockwise. And the terminal never touches the y-axis. So that's what it means. Okay. All right. So this, and of course, doesn't answer all the questions. We still have some unanswered questions as how to, but to make this commonly used questions, covered in this way, solely from the definition of the three pillars of trigonometry, ARD, we are going to conclude this lesson. Okay, you can see in all three examples from D to A, I hope you guys have a glimpse of either D, okay, we did A to D, and we also did D to A. Thank you for watching.